Welcome to the first Denford tutorial. Today I'm going to show you how to manufacture an F1 car using the F1 manufacturing fixture on the Router 2600 Pro. The first thing we need to do is we need to slacken off all the counterhead bolts to make sure that the fixture can be moved. We then need to get an F1 in school's model block held like this. We use these official model blocks. They're designed especially for the competition. As you can see, there's a hologram on there. These need to be presented at regional, national and world finals. The F1 in school model block sits in the fixture. It goes down into the V blocks, so we've got to make sure that it's straight. It sits the first with the tether line to the front of the machine. When this is in place, we now clamp up the fixture. What we need to do is we need to hold the spindle at the back and apply pressure. We then first tighten up the front clamp. Make sure it's nice and tight. We can now remove the band, which contains a hologram, and we need to keep that in a safe place for when we enter at the regional and national finals, because we need to put this when we submit our cars. The next thing we need to do is shut the door, and now we're going to have to connect to the machine. We connect to the machine using the Denford software called VR Milling 5. We double click on that. The page will load. This is the software that connects the machine to the laptop and is used to control the machine. So we click on machine. There'll be a slight click. Now we can home the machine, X, Y, and Z. We then need to put the machine into jog mode. So we click on jog, and now we can manually jog the machine. We pick up our keypad. We can then move the machine fast or slow using the feed rate override button. So I'm going to do it quite fast to get it into position. When I've got it nearly into position, I'm going to open the door and the feed will slow down dramatically. So now I open the door, I turn the cutter towards me, page down, now what I'm going to do is I'm going to put the software into step mode so that it steps at 0.1 each time I press the button. As you can see there, it's just moving in increments of 0.1 of a millimetre. I'm going to keep pushing the cutter into the block until it grips the piece of paper. Right, the piece of paper is gripped now. We're then going to go back into the jog mode after shutting the door. We're going to go into jog mode. We're going to click on full jog. We're then going to bring the machine to the right hand side of the block. We'll open the door again. Then going to get the piece of paper. We put the piece of paper
behind the cutter. And we're going to use this bolt here that's slightly tight as a pivot point. What we're going to do now is we're going to grab the fixture from the back, we're going to pull the fixture towards us, hold the pressure on and tighten up this bolt here. That's tight now, so the piece of paper shouldn't move. Make sure all the other bolts are tight. I always tighten the two front bolts first, as the fixture can move.
What we're going to do now is start the spindle manually inside the armouring 5. I'm going to take a pass across the model block just to make sure that the groove is the same thickness all the way down, to make sure that the block is parallel to the machine. So we start the spindle manually. And now we index the machine. Across. That's perfect. We've got no lines and we've got no ridges. The ridge is the same all the way across. Now stop the spindle in VR milling. What we need to do now is we're going to bring the tool over to the left hand side of the block, and we're going to set the datums X, Y and Z. Right, so now we're happy with the block, that it's aligned to the table. We now need to set a datum position. So the machine knows where the manufacturing fixture and the block is in relationship to the machine. So to do this, we go back into VR milling, we open offsets and tools. What we're going to do now is we're going to create a new offset. So to create a new offset, we click on there, create new work offset. We then click on there and we activate it. When it goes green, we can then name it. So we'll call it F1 fixture and press enter. What we're going to do now is we're going to go back into jog and we're going to move the tool to the left hand side of the block to start setting the datums. We're going to set the first datum, the X datum, then we're going to set the Y datum, and then we're going to set the Z datum. So we click back onto jog, page up, so we're free of the workpiece. We move the machine over. We get it somewhere near like we did before, and then we open the door. We bring the tool down. Just so we're below the workpiece. We make sure that the cutting edges of the cutter are pointing in the right axis, which is Y. And I'll get my trusty piece of paper. Put the machine back into step mode. And I step the cutter to the side of the block. Put the piece of paper there. And we step in. Wiggling the piece of paper until it grips. That's now gripped. We leave the machine there. We go into the work offsets and we're going to click on X axis. What we're going to do is we're going to click on the one with the blue button and it says set datum offset from current position. When we click on this button, it will offset the amount of the radius of the cutter. So the cutter is 1/4 of an inch, so half of 1/4 of an inch is 3.175. The tool is shown as blue in the diagram, so it's minus. We press OK. A figure will go in here. That's the distance from the home position of the machine, but if we look into program position, it will be minus 3.175. What that means is if we moved the cutter to the X0 position, the centre of the cutter would be bang on the side of the model block. What we're going to do now is we're going to set the Y. So we click on jog again. We then go back into the machine. We move the machine out. We're then going to move the machine down, and we're going to bring the cutter just so it's below the centre line of the spindle. There we go. Now I'm going to take the cutter in slightly, and we're going to put the machine back into step mode. So 0.1 of a mil step again. This time I'm going to put the piece of paper down the back of the cutter, and we're going to just step it in until it grips the cutter. That's gripped. So we're now touched onto the spindle. We need to go in now and we need to offset the cutter again. This time the value will be higher because we need to put in half the cutter radius plus half of the diameter of the spindle. So if we go into the Y-axis, not that one, this one, we go into this Y-axis, so it's 3.175 for the cutter, half of the cutter radius, and we need to do half of the diameter of the spindle, which is 6, because it's a 12mm spindle. So we put in 9.175. We press OK. What I like to do now is just check that we're in the right, that we've moved it the right amount. So we pull the piece of paper out. We go back into jog. We move the machine slightly away from the spindle so we don't catch the spindle on the way up. We page up. What I'm going to do now is go looking at the software. I'm looking for the Y-axis and I'm going to take the Y to 0. And we have a quick visual look. The cutter now is in line with the centre of the bar. So I now take Y as close as I can to 0. That's fine. Y 0. I'm now going to do the Z-axis. So leaving the jog in step, come back over to the machine. I now page down, putting the piece of paper underneath the cutter again, just until it grips the piece of paper. There we go. Piece of paper's gripped. I go back into the tool and offset editor, and I go Z, and I go to the bottom one because we're going to offset it again, but this time the tool is above the datum. So we're going to click on Z plus, and we're going to put in half of the diameter. So I've got a 12mm spindle, so we're going to put in 6. We click OK, and the value will change to 6mm. We now shut the tool on offset editor down so it saves them values. And now we send the machine home. Now we're happy that the fixture's square and the block is square in the fixture. We're now going to run the jig fixture calibration program. So if we go into File, Open, the program will be available following the link below the YouTube address. It's called Jig Setup. The first side we're going to cut is the right hand side. So if we click on that and click Open, the billet opens. Stop, rewind, start. Yes. Right, so when the program's finished, we now need to turn the block over and cut the left-hand side. So we undo the screws, all 4 screws. What we need to make sure is when we turn the block over is that we push the spindle back up against the stop again so that the block cuts the same on both sides. So we turn the block over, put the pressure on the spindle again, and again we tighten this end up first. Tighten it up the same amount of tightness as the other side. Call it in there. Right, so now we've tightened it all up and we're ready to go again. We go back into File, we go Open, and we're going to open the left-hand side of the program. Click on Left, Open, make sure you're in Auto, Stop, Rewind, Start. Yes. What this will do now, it will cut the exact same program, but it will be a mirror program of what we did on the other side. So it will cut down just below the centre line, and you will see if there's a step, and then we will adjust that accordingly. So now the program's finished, you'll see that we've got a step on the model block. If we were cutting an F1 in school's car, we'd have the step all the way down the back of the car. So we're going to take the block out and we're just going to measure what the step is. I'm going to put the block there. So now you get a digital vernier or a normal vernier, whatever you've got to hand. And we're going to put the vernier on there. And we notice that it's 1.6 millimeters out. So what we need to do is, because we've got 1.6 millimeters, we need to half that. So it would be 0.8. So if we go back into offsets and tools in here, and it's the y-axis where we're out, we're going to add 0.8 of a millimeter to 321.66. So now we're going to add the 0.8, so that would make it 322.46. We're going to press enter, and now we shut this down. We put the block back in. Right hand side again, so tether line to the front. We tighten the block back up, making sure that we've still got pressure on the spindle. Make sure it's nice and tight, just as it was before. Shut the door. What we need to do now is we need to reopen the first program we used. So if we go to reopen, it's test jig right hand side. What we're also going to have to do is move the datum point 10 millimeters in the x-axis, because if we run it again now, it will just cut the same bit of foam that we've already cut, so we won't be able to tell if it's made a difference. So the quickest way to do this is if you go into MDI,
and just put X10. When the machine has moved, it's showing 10mm in the X-axis. We're now going to go back into offsets and tools, and we're just going to zero the X-axis. So we're just going to click on there, and the X-axis is 0. We're going to then shut down offsets and tools, and we're going to run the right-hand side program again. Stop, rewind, start, and we'll put it again. So just as we did before, we've now machined this side. We're going to turn the block over and we're going to run the left-hand side program. It's quite a long-winded process this, but once you've done it, you've only got to do it once. So just an important note here, we're only doing this once. It seems like a really long-winded way of doing things, but we only need to do this once to get the datum set. Once the datum's set, you will be able to just cut cars every time you run the machine and the cars will be straight. This is literally just to set the fixture up for the first time, so as long as you don't take the fixture off the machine in future, it will stay fine. This is why we like to sell bigger machines, because you have a larger working envelope. So if we put a fixture on, because as you've seen it takes quite a while to set it up, we can put the fixture at the back of the machine and we can still use the full working envelope of the table. Right, so that's all tight again now. What we're going to do is we're going to reopen this time the left hand side. So we're going to click on left hand side and we're going to go auto and we're going to go stop, rewind, start. And the machine then will cut the left hand side, and hopefully the step will be less than it was before because we've changed that value by 0.8 of a millimetre. Right, so now that we've finished the machining, I'm going to take the block out and you'll be able to have a look at the difference in the step. Hopefully the step will have disappeared. It's trial and error. So if I take the block out now, you can see that the step is no longer there. I'd like to thank everyone for watching today. So as you can see, we've calibrated the fixture now, and what we're going to do next in our next tutorial video is we're going to load a brand new block into the fixture and we're going to import an STL file into QuickCam Pro, and I'm going to show you how to machine the car using the Denford 2600 Pro router. Thank you, goodbye.